Hello YouTubers, fellow hams. Well, I'm down at the bench and I thought I'd do a little video today on cleaning up slide switches. Well, I'm editing the ICO restore video, and a friend of mine suggested in a comment that I do a video on cleaning pots and controls in old equipment, coincidentally, and I let him know that yeah, that's actually what I had in mind. So that's what we're going to talk about today, cleaning up switches and potentiometers in old equipment. Let's go to the bench here, and I've set up a couple of switches and pots, and I'll show you what you need to do. Okay, here I've got a couple of potentiometers and a couple of slide switches. First off, potentiometers. These are variable resistors. Now I've opened up this one over here so I can show you the insides, and once you see how it works, what we need to do will become clear. So let's take the cover off this guy. Okay. This is the inside of a potentiometer. Now what you have here is let me get my glasses on. You have these two outer connection points, and this circular area here is doped with carbon for conductivity and other chemicals, and the density of that carbon and the chemicals they dope it with determines the resistance around the outer ring here. So let's say this is a 10K pot. That means that from this point to this point through this carbon there is 10 kiloohms or 10,000 ohms of resistance. Now the center tap goes to this conductive ring, which makes contact with the center of the wiper here, and then that comes out to these spring-loaded fingers which press against the carbon, and as you turn this, that wiper is rotated around here. So if the wiper is right out here in the middle, and this is a 10K pot, then from that wiper back this way there's 5K or 5,000 ohms of resistance, and from that wiper around this way there's 5,000 ohms of resistance. So that's how a potentiometer works. As you rotate that center shaft, you're moving those brushes along this area, and you're changing the relative resistance from this point to the wiper and this point to the wiper, and that gives you a variable resistance in two directions. So that's how a potentiometer works. Now the problem is this contact point along here. I'm pretty sure you can see this on the camera, but there's just this little dark line where the brush, the wiper, has been pressing against that carbon and frictionally moved back and forth over time. The brush itself, this may or may not show up in the camera, but right here in the middle where it makes contact with that carbon, there's a dark spot where it's been pressing against it. And as it moves across there, it grinds away microscopic bits of that carbon and creates dust, and that dust builds up and intermittently will lift that finger up off of the carbon as you're moving it around. You might have seen this or heard this on a volume control pot on an old piece of equipment. When you would adjust the volume, you'd hear, you know, as it's moving, and that's the dust and grit and dirt and the buildup on this contact point, raising that up off the carbon very briefly, and causing changes in that resistance and interruptions in that process. So that is what causes noise in a potentiometer. I'll put that back together later. Now, cleaning potentiometers. I picked this up at the hardware store, QD electronic cleaner. It's pretty cheap. It's formulated very similar to other products like Deoxit and other electronic cleaners, and it works just fine. There's a straw that you put in on the end, and most potentiometers, when you look at them, they'll have a gap. Right here, there's a little gap between the board and the shell, and that's where you'd put the straw. And you'd put that straw in that gap, and you give it a quick squirt to get some of that cleaner in there, and then you just exercise it back and forth a few times. And what that's going to do is that cleaner is going to clean the oxidation off the contact points, those little brass fingers or little gold-plated fingers, and it's also going to pick up the dust and grit and dirt and let that get pushed out of the way by the wiper. So that will clean the pot and eliminate the noisiness of it. Now the other common problem you have is with these slide switches. And the way these work inside, there is contact points and fingers again. And I'm gonna open this one up and show you what the inside of a switch looks like. Now these have, this metal shell is held against this board with these little, get in the frame Kevin, with these little curled over fingers. And if we pry those up a little bit, and then you can get in there with needle nose pliers and straighten those up to release the board. Now what you see inside the switch is contact points that come through to your solder lugs on the other side. And on the back of the switch will be some kind of a contactor that slides over those points. This one's spring-loaded. And sticky. It was sticking to my finger. You can see there's a little spring there that holds this contact and pushes it forward. And that would slide across these points, making contact across the switch. And these points will get dirty. They'll oxidize. Dust and grit will build up on them. Same deal inside this switch, and you can kind of see it on this one. There's a band there where that's been sliding over the contacts, and it's dirty there. Well, the same deal on these switches. Usually there's a gap right here, and you can just get your contact cleaner in there, just give it a squirt, and then exercise the switch. And you might have to do that 2 or 3 times to get it clean, but that will clean up those switch contacts and restore them to full function. Sometimes the switch is held together with these little bent out fingers, and you have to just sort of squeeze those in so that you can pull it off if you want to take the switch apart. Let's talk about that for a second. I had a problem with my BK Precision bench supply where it would not switch the high and low current in here, and I shot some video on that. Let's go to that video. Now it's old, and let me bring the voltage up. I've got a small power resistor hooked up here, and you can see the current comes up. So there's about 1/2 amp. But this switch over here for high or low range, I gotta wiggle it around to get it to make contact. I don't even know if the high range is working. Yeah, I can almost get the high range to work. So this switch is bad, and I cleaned it once before and thought I had it solved, but it's just not working. Now this is a panel switch, which is one of these. The problem is these switches are mounted by 2 screw holes here, and usually you've got 2 screw heads on the front of whatever the device is for the screws that go through and hold the switch in. And therein lies the problem. On this power supply, we've got this really nice front adhesive panel here that sits over that, and the screws are underneath there. But this is a coated plastic and metal panel, and in order to get that switch off, I would have to peel this up, which would be messy and undoubtedly impossible to get perfectly back down. I don't want to ruin the look of this thing. Okay, so I've been taking my contact cleaner rag, got my finger sticking through here, and I hit the rag with the contact cleaner, and I hold this and I just rub those contacts real good. I don't know if you can see that. They're nice and shiny now. Let's zoom in. You can see this contacts down in the switch. are all shiny, and these are silver plated, and they're all shiny, so we should have real good electrical connection now. Well, we're all back together, and it is working. Switch works perfectly now. No intermittency to it at all. High mode, low mode. So that's how you deal with controls in old radios and old gear when you've got some noisy controls, and that's how you clean them up. I hope this video has been helpful to you. As always, if it has and you liked it, give me a thumbs up. If you haven't subscribed, please do, and you'll get a notification every time I upload a new video. Thanks for watching.